just before I get started with this example, again, you may come across a tutor or see in a textbook somewhere the suggestion that you put together a table. I'm not going to, you won't see me use a table. I believe the tables look something like, they might have x, the function value at x, and 4 times the function value at x, and 2 times the function value at x. And that would be your very first one. I suppose the ones, the odds, odd number, 1 and 2, it's odd is here because remember it was 4 times the odd, so you'd have an entry there. But for the even, you'd have an entry here because for every even value you multiply, function value, you multiply by 2, etc. Like I said, you're not going to see me do it that way. I stick with my understanding of what's going on. Here I've put out again another bit of a formula that you may see, and again some people will find it confusing because it's different notation. It's only different in that we're now calling rather than the function value at A, here it's being referred to as y0, the first y value, and the function value at B being referred to as yn. Then after y0, and in some ways this sort of makes sense to me, that if I've got a function and I've got my various x values, my various function values, why not call this one y0? It's starting at A. And why not call this one y1, y2, y3, blah, blah, all the way up to yn? So all of these are going to be either even or odd function values, and if they're odd function values, they will have 4 times that function value according to the rule. So it's 4 times, and this is the odd group of y values, and 2 times the even group. So, and again, it's h on 3, and h is whatever the distance from B minus A divided by n, divided by the number of strips that you've got, which is not the same as the number of applications, and that's where people don't pick up on the finer differences and end up with the wrong values, wrong numbers. I just prefer you to go back to your basic understanding of one application, and that's here. One application, 3 function values, h is half the distance from B minus A, that's what h is, and I suppose I should write that, h is half of that distance, do B minus A and then halve it, and the rule is all of h divided by 3, and that's the reason I think I went into that before about why a 6 turns up. So, yet again, another variation, and yet again, another variation of how the rule is presented. To me, the very best is to understand the rule and write out as many applications, and don't even go for recognizing patterns and a shortcut. That's always an option. Don't try to look for any pattern. Don't try to look for any shortcut, and just write out as many applications as needed. So in this example, we're going to find the approximate area under the curve. Y is 1 on x, from x is 1 to 2, using Simpson's rule to the whole interval. So 1 on x would look like this, from 1 to 2. We need to know our function values, and we need to have the middle. If we draw the graph, then it's very easy to see h in this case for A, h is 0.5, we want the function value at 1, we'll want the function value at 1.5, and we'll want the function value at 2. And we'll put those into the formula. A is approximately equal to h on 3, function value at 1, function value 4 times the middle function value, which is at 1.5, and straight out function value at 2. So you can see there I've written out the rule, substituted these values. Oh, you can't, I've actually got f of 1, put 1 into here and you get a 1. At 1.5, 1 divided by 1.5, 1 divided by 3 on 2 is 1 times 2 on 3, so that's equal to 2/3. And at 2, 1 on 2 is a half. So you can see those values coming up, and provided I've put that into my calculator correctly, we get 0.69 or 25 on 36. You'll probably see that, yeah, that's reasonable. If I took the whole area of 1 unit by 1 unit, it gives me 1 square unit, and I've got less than that. So 0.64 is a good approximation. For the example 2, we've asked to get the area with 2 applications or 5 function values. So you could see they would be the equivalent to function at 1 or y0, y1, y2, y3, and y4. 1, 2, 3, 4, 5 function values. We've got the 2 that are our limits, the y0 or the f1 and the f at 2. Now another name for f at 2 would be y4. We've then got 2 of them at the dotted line, so they're our odd function values, and they need to be multiplied by 4 odd functions, and we can see that this would be 1.5, and halfway between 1 and 1.5 is 1.25, and halfway between there is 1.75. That gives us h as 0.25. The distance between our values is 1/4. So we would have 1/4, 0.25 divided by 3, f of 1, and I'll pause the video and put those values in. So now putting those actual values in for subbing these numbers into the function, and going to my calculator. Hopefully I've done it right, and it looks like I have, because now I'm getting 0.69325, and it's similar to this answer. It should be a little bit more accurate because I've done more applications. I think it should be right to go ahead and do questions from 11J now.